Alright, so for this video, we're going to talk about mathematical induction. And to formally start, allow me to define what mathematical induction is. It is a special way of proving series to be true for any values of n, where n is greater than or equal to 1. And it has only 2 steps. Some books or some papers, sinasabi nila 3 steps, no? Wala namang kaso dun. On this lesson, i-introduce lang natin siya in terms of 2 steps. Okay? For the step 1, show that it is true for the first one. So you're going to let the variable n as equal to 1 or 2 or 3. Okay? Then step 2, show that if it is true for any value, so you're going to let n as, let's say, k, then it is true for the next value, that is k plus 1. Okay? So, ngayon ipapakita natin kung paano gumagana itong strategy na to to prove na yung mga series na mayroon tayo or yung general formula para sa mga series ay gumagana sa lahat ng values ng n. Alright, we all know that arithmetic series formula is S sub n equals n over 2 times the sum of 2a sub 1 and the quantity of n minus 1 times d. Okay. Now, let us consider the series. Okay, 1 plus 2 plus 3 plus 4 plus 5 plus all the way up to n. Okay. Alam natin sa series na to ay nagmula siya sa arithmetic sequence na ang common difference is 1 and yung ating first term, which is a sub 1, ay equal sa 1. And yung common difference nga, gaya sabi natin kanina, is also 1. Okay. Then gamitin natin yung arithmetic series formula to determine the general form ng ating series. So magkakaroon tayo dito ng S sub n. Okay, so gawin natin to by arithmetic series. Okay, we have S sub n equal n over 2. So n over 2 times 2a sub 1. Ang alam natin si a sub 1 is equal to 1. So palitan lang natin siya ng 1 plus n minus 1 d. D is equal to 1. So, palitan lang din natin siya ng 1. Then, simplify. So, once na sinimplify natin to, we have S sub n equals n over 2. Then, 2 plus n minus 1. Okay. Sa loob ng bracket, mapapansin natin, pwede natin i-simplify yung 2 minus 1. So, magkaaroon tayo dito ng S sub n equals n over 2. 2 minus 1 is 1. Then, matitira yung ating variable n sa loob ng bracket or gagawin na natin siyang parenthesis. Okay. Now, the general formula para sa ganitong series ay n over 2 times the quantity of n plus 1. Now, let us show that the series na 1 plus 2 plus 3 plus 4 plus 5 hanggang makakating tayo kay n ay equal dito sa nabuo nating general form, which is si n over 2 times n plus 1. Okay. Dito, papasok yung ating mathematical induction. Paano natin ipapakita na ito ay equal lang naman sa isa't isa? Una, ang sabi sa ating definition ng MI or mathematical induction, show that it is true for the first one. So, ililet lang natin na 1 yung variable n. Now, let us proceed by mathematical induction by MI or mathematical induction. So, we have the step 1. Okay. Let n is equal to 1. Since 1, yung value ng n, kailangan lang natin kunin yung first term para sa left side. So, meron tayong 1 equal. Okay. Usog lang natin ng konti. 1 equal. Then, lahat ng n, papalitan lang natin ng 1 dun sa right side. So, meron tayong 1 over 2 times the quantity of 1 plus 1. Okay. Simplify. 1 equal 1 half times 1 plus 1. 1 plus 1 is 2. So, gagawin lang natin tong 2. Okay. Then, kung mapapansin natin, cancel tong part na to. And may natira tayong 1 sa right side. Therefore, we can say na totoo yung ating series at n is equal to 1. Okay. How about if n is 2? Okay. Pag n is 2, kailangan lang natin kumuha ng dalawang terms. So, 1 plus 2. So, sa left side, we have 1 plus 2 equal. Sa right side, palitan lang natin lahat ng nakita nating n as 2. We have 2 over 2 times 2 plus 1. Okay. As we simplify, 1 plus 2 sa left side, that is equal to 3. Equal, 2 plus 1 is 3. 2 over 2, this will be equal to 1. So, we have 1 times 3. And, napakita din natin na ito ay totoo at n is equal to 2. Ngayon, pwede nyo i-verify na ito rin ay totoo at n is equal to 3, at n is equal to 4, at n is equal to 5. Kaya lang, medyo matatagalan tayo kapag inisa-isa natin sila. Diba? Since napakarami ng natural numbers, kaya gagamit tayo ng step 2. Step 2. Dito, ipapakita natin na totoo siya sa kahit na anong numbers. Dahil hindi naman natin pwedeng manu-manuhin ito. At n is equal to 3, at n is equal to 4, and so on. Now, dito, ilalet lang natin yung n as equal to k. We assume, no? Ina-assume lang natin na ang n ay equal sa k, where k is any number, any natural number. Okay. Now, sa left side, being n is equal to k, we have 1 plus 2 plus 3 plus 4 plus 5 plus all the way up to k. Then, sa right side, lahat ng n na makikita natin ay papalitan lang natin ng k. So, we have k over 2 times k plus 1. Ina-assume natin na ito ay totoo. Okay? If n is equal to k is true, dapat yung kasunod nito, which is si k plus 1, is also true. Let n is equal to k plus 1. Okay. Now, yung left side, magkakaroon tayo ng 1 plus 2 plus 3 plus 4 plus 5 all the way up to k. Then, ang kasunod ni k ay k plus 1. Now, sa right side, lahat ng makikita nating n, okay, ay papalitan lang natin ng k plus 1. Now, we have k plus 1 over 2 times k plus 1 plus 1. Ngayon, paano natin ipapakita na ito ay equal sa isa't isa? Okay. Kung mapapansin nyo, itong nasa left side, familiar po ba kayo dyan? Ito po yan. Okay? So, yun yung nasa part na at n is equal to k. Inassume natin na yan po ay equal sa k over 2 times k plus 1. So, pwede natin palitan yan, yung part na to, as k over 2 times k plus 1. Now, meron pa tayong plus k plus 1. So, idudugtong lang natin yun. Okay? And that is equal to k plus 1 over 2 times k plus 1 is k plus 2. Okay? Ngayon, paano natin ipapakitang ito ay equal lang sa isa't isa? Isi-simplify lang po natin sila. Okay? Ngayon, yung left side, pwede natin tong isulat. Gamitan lang natin ng onting algebra. This is equal to k times k plus 1 plus 2 times k plus 1 all over 2 equal, sa right side, sulat lang natin siya ng maayos. We have quantity k plus 1 times quantity k plus 2 all over 2. Okay. Paano natin yan gagawin yung magkaparehas? Okay. Kung mapapansin natin, dito sa equation na to, okay, k plus 1 is present at each term. Pwede natin yun i-factor out. Now, kapag finactor out natin siya, makakakuha tayo ng k plus 1 times k plus 2 all over 2. Okay? Kasi kapag ginamitan mo yan ng distributive property, so we have this one, k plus 1 times k is k times quantity k plus 1. Then, quantity k plus 1 times 2 is 2 times quantity k plus 1. So, iisa lang po sila. Finactor out lang natin yung binomial na k plus 1. Okay, so, delete lang natin to. Okay. Sa right side, kung mapapansin po natin, susulat mo lang yung nasa right side diba? So, meron tayong quantity k plus 1 times quantity k plus 2 all over 2. And na yun, napakita natin na yan po ay equal. And yan po ay totoo sa lahat. Okay, since naipakita natin or na-show natin na ang n ay gumagana at k plus 1. And that is the end of our proving that this arithmetic series is true for any values of n. Now, another example. Consider the series 1 plus 3 plus 5 plus 7 plus all the way up to 2k minus 1. Palitan natin to siguro to ng n. Yan, gawin natin tong 2n minus 1 tas n squared. Okay. 1 plus 3 plus 5 plus 7 plus dot 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 plus 2n minus 1 is just equal to n squared. Okay. Ito ay sum or series ng mga odd numbers, no? Odd numbers. So, paano kaya natin mapapakita na they are equal to each other? Of course, using mathematical induction. Okay. First step. Step 1. Okay. Let n is equal to 1 or show that it is true for the first one. Okay. Since n is equal to 1, kailangan lang natin kunin yung first term. So, we have 1 equal, okay, that is equal to n squared. So, n is equal to 1, we have 1 squared. And 1 is equal to 1 squared, which is 1. So, 1 is equal to 1. Okay. Let n is equal to 2. So we have two terms, 1 and 3. So 1 plus 3 sa left side. Sa right side, we have 2 squared. Okay? Since n is equal to 2, we have 2 squared. 1 plus 3 is 4. 2 raised to 2 is also 4. So they are equal to each other. Halimbawa, let n is equal to 3. Since n is 3, we have to take only 3 terms. So we have 1 plus 3 plus 5 equal 3 squared. 1 plus 3 plus 5 is 9. 3 squared or 3 times 3 is also equal to 9. It's true. Hindi natin kaya yan isa-isahin o manu-manuhin. And 4 and 5 and is equal to 6 and so on and so forth. So, papaganahin na natin yung step number 2, which is isi-show natin that it is true for any values of k. No? So, let n is equal to k. Step 2. Let n is equal to k. I-assume natin na equal siya sa k. Okay? So, we have 1 plus 3 plus 5 plus 7. 1 plus 3 plus 5 plus 7 plus dot hanggang makakating ka kay 2k minus 1. Since k plus 1, yung next po sa k, no? Here, ang next po sa 2k minus 1 is 2 times k plus 1 minus 1. Okay? Then, sa right side, we have k squared. Papalitan lang natin siya ng k plus 1. Okay. So, everywhere you see a k, we will replace it as k plus 1. Okay. So, we have k plus 1 squared. Sa left side, kung mapapansin po natin, to evaluate this, okay, itong part na to, ay ito. At siya ay equal sa k squared. So, pwede natin itong palitan as k squared. Okay. Next, we have additional of 2 times k plus 1 minus 1. So, to simplify, we have 2k, okay, 2k times 2, or plus 2, then we have minus 1. Okay. Sa right side, we have quantity k plus 1 squared. Okay. Now, simplify, yung nasa left side, we have k squared plus 2k, 2 minus 1 is positive 1, equal quantity k plus 1 squared. Kung mapapansin din natin sa left side, this is factorable. K squared plus 2k plus 1 is equal to k plus 1 times k plus 1 equal quantity k plus 1 squared. Then, yung nasa left side is also, or it can be written as k plus 1 squared equals, then equal na sila ngayon, k plus 1 squared. And we prove na ito ay gumagana sa lahat ng values ng n. Kahit anong value ni n, it is always true. Now, let us have our last example. So, papakita natin na yung nasa left side is equal to the right side for all values of variable n. Okay. So, we have 1 plus 2 plus 2 squared plus all the way up to 2 raised to n minus 1. And that's equal to 2 raised to n minus 1. Of course, by mathematical induction, step 1, show that it is true for the first value. Let n is equal to 1. Since n is 1, kailangan lang natin ng 1 term. So we have 1 is equal to, palitan lang natin ng 1 lahat ng n sa right side. So we have 2 raised to 1 minus 1. Simplify. 1 equals 2 minus 1. And we have 1 is equal to 1. Let's check that it is true for n is equal to 1. How about n is 2? If n is 2, so kailangan lang natin ng dalawang terms. So we have 1 plus 2 equal 2 raised to 2 minus 1. Palitan mo lang ng 2 yung n. So we have 3 sa left side. On the right side, we have 2 raised to 2, which is 4 minus 1. And there you have it. 3 is equal to 3. And that is checked for n is equal to 2. If n is 3, kailangan lang natin ng tatlong terms. So we have 1 plus 2 plus 2 squared equal. Palitan mo lang ng n yung 3. Palitan mo lang ng 3 yung n. We have 2 raised to 3 minus 1. Left side, simplify. We have 2 squared, which is 4, plus 2, 6, plus 1, 7. Okay. On the right side, we have 2 cubed, which is 8, minus 1. And ito na, 7 is just equal to 7. And that is also true for n is equal to 3. Para naman sa ating step 2, okay, sa step 2, ipapakita natin na yan ay totoo sa k. Where k is any natural number, since di natin kaya manumanuhin yan, i-assume natin na equal siya sa k. So we have 1 plus 2 plus 2 squared plus dot plus we have 2 raised to k minus 1. 2 raised to k minus 1. And that is equal to 2 raised to k minus 1. Alright. Now, if inassume natin na ito ay equal for some k, dapat may pakita rin natin na ito ay totoo for the next number. And that is k plus 1. So, let n is equal to k plus 1. So, we have 1 plus 2 plus 2 squared plus all the way up to 2 raised to k minus 1. And yung kasunod nito is 2 raised to k plus 1 minus 1. At yung nasa right side, papalitan lang din natin yung k ng k plus 1. Okay. On the left side, kung mapapansin po natin, itong part na to is ito. At yan ay inassume natin na equal sa 2 raised to k minus 1. Yan. Okay. So, pwede natin yan palitan ng 2 raised to k minus 1. Then, bring down lang natin yung color white, itong part na to, that is plus 2 raised to k plus 1 minus 1 equal, sa right side, we have 2 raised to k plus 1 minus 1. Okay. Now, let us simplify. 2 raised to k minus 1 is just equal to 2 raised to k minus 1 plus itong 2 raised to quantity k plus 1 minus 1. So, cancel yung 1 natin dito. Magiging 2 raised to k. Okay. And that is equal to 2 raised to k plus 1 minus 1. Yan. Okay. Now, 2 raised to k plus 2 raised to k, yan po ay magiging 2 times 2 raised to k, then minus 1, equal 2 raised to quantity k plus 1 minus 1. Ngayon, kung mapapansin natin, by law of exponent, so onting review lang tayo, by law of exponent, alam natin na ang x raised to m plus n is just equal to x raised to m times x raised to n. Right? So, itong part na to, ito, we have 1 as an exponent here. So, ito ay magiging 2 raised to quantity 1 plus k minus 1. So, equate natin yan sa 2 raised to quantity k plus 1 minus 1. Addition is commutative. So, pwede ito maging 2 raised to k plus 1 minus 1. And on the right side, makikita na natin yung kaliwanagan, no? So, ito ay yung right side magiging, as is lang yan, 2 raised to quantity k plus 1 minus 1. And there you have it. They are equal to each other. Therefore, we can say that yan, this series, itong part na to, is true for all values of n where n is greater than or equal to 1. Okay. It is true for all natural numbers rather. Okay. So, that's it for our mathematical induction. Hope may natutunan kayo. Kung meron man, kindly like and subscribe this channel. Maraming salamat. Peace.